Hi, and welcome to the Algebra 2 Unit 9 Rational Functions Review video. Let's get right to it. Right here in number 1, I see that we are adding two fractions together. Adding means we need a common denominator. Also, I see we have a quadratic in the bottom, so before we do anything, we need to see if there's anything that needs to be factored, and this first denominator needs to be factored. It's a quadratic, so we do the ABC method or the T-chart with C on top, 15, and 2 on the bottom. Factors of 15 are 1 and 15, 3 and 5. Now, which of these has a difference of 2, 3, and 5? We need them to add up to a positive 2, but multiply to a negative 15. So we're going to have a positive 5 and a negative 3. Now, we need to create common denominators when we have addition and subtraction problems. So here, in the right denominator, we have x minus 3. And in the left, we have an additional factor, x plus 5. So we need to give that additional factor to the other fraction. And again, this only happens for addition and subtraction. What you do to the bottom of one fraction, you have to do to the numerator as well. All right, now let's go ahead and distribute this too. And we're going to make a big fraction all over our common denominator of x plus 5, x minus 3. All right, so in this first fraction, we have x plus 5, nothing to change there. And we have a plus sign. 2 times x is 2x, and 2 times 5 is 10. Now we need to combine common like terms in the numerator. So we can combine 5 and 10, and we can combine x and 2x. X plus 2x is 3x, and 5 plus 10 is 15. Now, what I see here is that this numerator needs to be factored. 3 and 15 are both divisible by 3. So if we factor out a 3, we will be left with 3 times x minus 5, or sorry, x plus 5. Now, can that factor cancel anything out? Yeah, it cancels out. I'm trying to erase these highlighters. Sorry, they're distracting me. Oh my goodness. Okay, boom, boom. All right. Over here on the right, we have x plus 5 over x plus 5. Those cancel out, and all we're left with is 3 over x minus 3. That is our final answer. All right, number 2, we have another addition problem here. So I see the first denominator needs to be factored. How does it need to be factored? It's a quadratic. There's 3 terms and a square. That tells us it needs to be factored. So quadratics are factored using ABC or the T-chart. Factors of 10 are 1 and 10, 2 and 5. Which of these adds up to 7? 2 and 5. So our two factors here are x plus 2 and x plus 5. Now, over on the right, we have x plus 5, but we don't have x plus 2. So we need to multiply this entire fraction by x plus 2. That way, the denominators on both fractions match. Once the denominators match, we can put them all over the same common denominator. So on the left, we have x. Work, that would be great. On the left, we have x. And on the right, we have to distribute the 3. So we have x plus 3 times x, so 3x, and 3 times 2, so 6. Now we need to combine our like terms. X and 3x is 4x. X plus 3x is 4x. We have 4x plus 6. Now we're not done yet. Just like the last problem, 4 and 6 can both be divisible or divided by 2. So dividing by 2, that leaves us with 2x plus 3 on the inside. Now, unfortunately, that still doesn't cancel anything out in the denominator, but our answer is in complete factored form. So leave our answer just like that. All right, moving on to number 3, these are subtraction problems. And anytime we have a subtraction problem, we need to change it to addition and distribute the negative to the following numerator. I saw a lot of people on their test just changing it to a positive and not changing anything else. So we need to distribute the negative to everything in the following numerator. Let's do the same thing for number 4. Number 4, we have another subtraction problem, so we say plus, change everything in the numerator to a negative. All right, back to number 3. When we add or subtract, we need to create common denominators. On the left, I have x plus 2. On the right, we have x minus 5. How do I make them match? All we do is take the first one and multiply it to the second one, and the denominator. Then we are going to take the second one, multiply it to the first one in the numerator and the denominator. Now we have matching bottoms. So let's go ahead and say our new fraction is something over x minus 5, x plus 2. Now to get our numerator, we are going to have to distribute the 7 to that set of parentheses and the 4 to the negative 4, to this set of parentheses. Starting with the 7, we have 7 times x, so 7x. 7 times negative 5 is negative 35. On the right, we have negative 4 times x for negative 4x, and negative 4 times 2, which is negative 8. Now we can go ahead and combine like terms in the numerator. 7x minus 4x is 3x, and then we are also going to combine the constants, negative 35 and negative 8. Writing here, still all over the same common denominator. 7 minus 4 is 3x, and negative 35 and negative 8 is a negative 3. This is our final answer right here. Moving on to the next problem, number 4. Another subtraction problem. So what do? We change it to plus and distribute the negative to the following numerator. I see a denominator here, 2 denominators that need to be factored. They're both quadratic, so I'm going to factor them starting with the t-chart. Over here we have negative 3 on top and negative 2 on bottom. Factors of 3 are only 1 and 3. Now, these numbers need to multiply to a negative 3, so one of them will be negative. And they need to add up to a negative 2. So 1 minus 3 is going to give us that negative 2. If we did 3 minus 1, that would leave us with a positive 2, and we need it to be negative. 1 minus 3. Now for the other one. At the top, we have negative 2, and at the bottom, negative 1. Factors of 2 are only 1 and 2. How can they add up to a negative 1 and multiply to a negative 2? The 2 needs to be negative. 1 minus 2 is negative 1, and 1 times negative 2 is negative 2. All right, now because we're adding or subtracting, we have to have a common denominator. I see that both of my denominators have x plus 1, but the first fraction does not have x minus 2, and the second fraction does not have x minus 3. We're going to take this and multiply it here and here. Then we're going to take the other fraction, x minus 2, and multiply it here and here. Now we have x minus 2, x plus 1, and x minus 3 all in the denominator. Let's go ahead and write one big fraction all over the common denominator. Now for the numerators, we're going to have to multiply those out. So we're going to have to double distribute on the right and single distribute on the left, and then single distribute on the right. So starting with the first one, we have x times 7x. That is 7x squared. And we have x times negative 1, negative x. Now we have negative 2 times 7x, or negative 14x, and negative 2 times negative 1 is a positive 2. Moving on to the right, we have negative 6x times x, negative 6x squared, and negative 6x times negative 3x. Now to combine our like terms, we have 7x squared minus 6x squared, which is just a single x squared. Then we have to combine the plain x's. Negative x minus 14x plus 18x. So this right here, negative 1 and negative 14 is negative 15x. 18 minus 15 is 608, so 3x. And then last, hanging out at the end, we have a constant of 2. All right, now we're not totally done here. We do need to factor this quadratic here. We have 2 at the top and 3 at the bottom. Factors of 2 are 1 and 2. So our two factors are going to be plus 1, x plus 2. And we can cancel things out again. We have a matching x plus 1. And what we're left with is x plus 2 over x minus 2 times x minus 3. That is our final answer. All right, let's take a look at number 5. Here we are multiplying. When we're multiplying, we don't need a common denominator. All we need to do is factor and cancel things out, and that's it. So here, factoring the top, I'm going to factor in the margins. We have 6 on top, 5 on the bottom. This is what we're factoring first. So 6 on top and 5 on the bottom. We have factors of 6, 1 and 6, 2 and 3. Now, which of these adds up to 5? So our factors are x plus 2, x plus 3. And if I'm moving too fast for you, you can slow the video down using the little gear shape in the bottom right-hand corner of this video. All right, now let's factor the bottom. We have negative 20 on top and negative 1 on the bottom. How am I getting the negative 1? Right here, this coefficient. So factors of 20 that add up to 1, I know that's 4 and 5. Positive 4 minus 5 gives us that negative 1. Cool. Moving on to the next numerator. We have negative 4 on top and 3 on the bottom. Which of these, how can we make this add up to 3 if one of them needs to be negative? A negative 1, x minus 1, x plus 4. And again, have you done the delta math? If you haven't done the delta math, you haven't had to practice factoring. And if you used AI, well, you're still going to be lost because this is not going away. Factors of 2 are 1 and 2. How can we make them multiply to a negative number but add up to a positive 1? Positive 2 and minus 1. Plus 2 minus 1. All right, now we are done factoring. And we can go ahead and start canceling things out. We need to cancel one pair. When we talk about pairs, it's 2 things that get canceled. I saw way too many people canceling like three separate factors out together. A pair. You have a pair of shoes on your feet. How many shoes is that? Two. So why are we canceling three? Don't do that. It's a pair. One and one. So we have a matching x plus 2. We have a matching x plus 4. We have a matching x minus 1. And what are we left with? X plus 3 over 5. Awesome. Moving on to number 6. Multiplication again. We need to factor this, this, and this. How do I know that these need to be factored? How do I know that that first numerator does not need to be factored? Look at the numerator. We have a single x being added to something. The next numerator, we have 2 times x being added to something. And in the bottom, we have 10 times x being added to something. Then over here, we have x squared. Notice that there's way more going on with the x than here. That means we probably have to factor that, or at least we have to try. So I'm actually just going to erase this so we have space right here. Looking at this problem, starting with that first denominator, we have 2 terms. There's only 2 terms. You're either factoring difference of squares or you're factoring out the GCF. What's GCF? Greatest common factor. Is 20 divisible by 10? Yeah, it is. When we divide by 10, we are left with 10 times x plus 2. Next numerator. 2 and 2, what are they both divisible by? They're both divisible by 2. All right. And on the bottom, we need factors of 3 that add up to 4. Factors of 3 are 1 and 3. Do 1 and 3 add up to 4? Yeah. Now that we have all of our numerators and denominators factored, we can totally start canceling things out. Again, only one factor cancels out with a factor another one, but one has to be in the numerator and one has to be in the denominator. So x plus 3, those cancel out. This x plus 1, those cancels out. What are we left with? 2 over at 10 times x plus 2. All right, well, actually, we're not done here. These coefficients, 2 over 10, we can simplify that fraction by dividing both by 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. This is our final answer. Number 7, we have a division problem here, so we need to keep, change, flip. That's for both number 7 and number 8. Keep, change, flip. All right, before we do any keep, change, and flip, we need to factor everything. Every single one of these numerators and denominators need to be factored. So starting with the first numerator here, we start with 10 on top, or negative 10 on top, and negative 3 on the bottom. Factors of 10 are 1 and 10, and 2 and 5. Now, which of these add up to 3? 2 and 5. Which one needs to be negative to add up to a negative 3? Positive 2 minus 5. X plus 2, x minus 5. Next, negative 6 on top, negative 1 on the bottom. Factors of 6 are 1 and 6, and 2 and 3. 2 and 3. Which one needs to be negative? The 3. All right, next fraction, we have x squared minus 2x. There's only 2 terms here, so what is the GCF between x squared and 2x? There's an x. And on the bottom, again, an x. Now we need to keep the first fraction. change to multiplication and flip that last fraction. Again, this is only done for division. Now that we have factored, we KCF'd, now we need to cancel the matching factors. Well, not as much stuff canceled out as I wanted it to. So okay. Go ahead and combine everything at the top and everything left in the bottom. All right. Oh, actually, coefficients can cancel out. X over x is 1. So our final answer is right here. X plus 2, x minus 5 over x minus 2, x minus 3. Number 8. More factoring. Starting with the numerator. -8 on top, 2 on bottom. So we have 2 and 4, where the 4 is negative and the 2 is positive. Now first denominator. Only 2 terms, so we're going to factor out a GCF. Is 24 divisible by 8? Yeah. 8 times 3 is 24. All right, next, 2x minus 8. Is 8 divisible by 2? Yeah. 8 divided by 2 is 4. And this last one here, we have 12 on top, 7 on bottom. Our factors are going to be 3 and 4. Now we're ready to keep, change, flip. Keeping that first fraction. Changing to multiplication. And flipping the last one. Now we can cancel out matching pairs. And what we are left with is x plus 2 times x plus 4 over 8 times 2. Let's write that out. That's our final answer. All right, let's go to the next page. I think y'all's is a little bit out of order, so we're moving on to number 9, which is more practice with the review, or sorry, operations. All right, so this is back to addition. When we add, we need a common denominator. Look at our denominators. Are they the same? Yeah, they are. So let's go ahead and combine the numerators all over the common denominator. So here we have n plus 2 plus 6. What's 2 plus 6? 8. All over our common denominator. Now in the denominator, we can definitely factor out a 4, leaving us with n minus 1, but that doesn't cancel with the top, so it's totally okay to leave it like this or the way we had it before. Either one is fine. All right, moving on to number 10. Number 10, we have another addition problem. Do we have common denominators? Well, off the bat, they do not look the same, but this needs to be factored. This is difference of squares. And difference of squares says we can square root both terms, and the ones we're left with have a positive one and a minus one. Now we can see that our denominators do match. So we can go ahead and combine the numerators over the common denominator. So we have 5 plus 3x. Well, 5 does not have an x, so 5 and 3x cannot be combined. We'll go ahead and write it in standard form anyways, over common denominator. That's answer there. All right, number 11, subtraction again. Anytime we subtract, we want to make it easier for us and change it to addition, but that's not the only thing we're doing. We need to change or distribute the minus sign. So everything in the following numerator, those signs need to change. Now, we need to create common denominators. This denominator on the right definitely needs to be factored. So let's put the negative 24 on top, the negative 2 on bottom. Here we have 1 and 24, 2 and 12, 4 and 6. Now, which of these have a difference of 2, 4, and 6? In order for them to add up to negative 2, the 6 needs to be negative. Now we can see that our denominators match. We have an n plus 4 and an n plus 6. Now, oh, we're not done yet. Let me rewind right here. Well, never mind. Our denominators match, so we're good. Put that back there. All right, denominators match. Bring it to the bottom, and we can combine the numerators all over the same denominator. Let's combine our like terms. We have n minus 2n, so 1 minus 2 is negative 1. And negative 1 minus 4, oh, there's an n here, sorry. Negative 1 minus 4 is negative 5. All right, so negative 1n minus 5 all over our common denominator, n plus 4, n plus 6. Okay, so we have I guess that's it. All right, moving on to the next one. Another subtraction problem. So we need to change it to addition and distribute the negative to the entire next numerator. Now, both of our denominators are quadratic, so we need to factor these. I'll start with this one. We have negative 15 on top, 2 on the bottom. So the factors that multiply to 15 and add up to 2 are going to be 3 and 5. We need them to add up to a positive 2. So we're going to have a positive 5 minus 3 to get that positive 2. And again, if factoring is difficult for you, you need to practice. I don't know what else to tell you there. We've done it so many times this year. You need to be practicing your factoring. Yeah. Now, the other denominator here, we have a negative 10 at the top, a positive 3 at the bottom. So factors of 3, we got 2 and 5. Factors of 10, sorry. So how do they add up to 3? We have a positive 5 minus 2. Minus 2 x plus 5. Okay, now let's see what we got. On both denominators, we already have x plus 5. But on the left, we have x minus 3, which we don't have here, so we're going to need that here and here. And on the right, we have x minus 2, which we don't have on the left, so we're going to need that here and here. Okay, now that our denominator, we have blue, pink, and yellow, x minus 2, x minus 3, x plus 5, and both, we can make a big fraction all over the denominator. And for the top, we're going to distribute the 5x and distribute the negative 7x. Let's do that now. 5x times x, 5x squared. 5x times negative 2 negative 10x. Negative 7x times x is negative 7x squared. And negative 7x times negative 3 is a positive 21x. Now we need to combine like terms. We have 5x squared minus 7x. That gives us a negative 2x. Make this a little smaller for my space. We have a negative 2x squared. Then combining the x's, we have negative 10x plus 21x. So that's a positive x. Okay, I'm checking my notes, realizing I did something wrong on the problem, not what we're doing now. Okay. All right, now looking at the numerator, negative 2 and 11 don't have anything in common except x. So we can factor out an x. The first term is also negative. Typically, when that first term is negative, we need to also factor out the negative. So factoring out a negative x from here, we're going to be left with 2x minus 11. So writing our final answer, we have negative x times 2x minus 11 all over x minus 2 minus 3 and x plus 5. All right, let's take a look at number 13. Here's multiplication. Multiplication is the easiest. All we have to do is factor and cancel out. So here we have x plus, let's just start with the first one. Here we have 9 on top, 6 on the bottom. Factors of 9, 1 and 9, 3 and 3. There it is, 3 plus 3 is 6, 3 times 3 is 9. Next denominator, 8 and 24, what do they both have in common? 8. We're left with 8 times x plus 3. On the right, we have x squared minus 49. This is difference of squares. Square root both terms. We're left with x and 7. Now this is not only one factor. We have a negative and a positive. And the final denominator is 21 on top and negative 4 at the bottom. So factors of 21 are 1 and 21, 7 and 3. There it is. 7 and 3 have a difference of 4. But which one needs to be negative to add up to negative 4? It needs to be a negative 7 plus 3. All right, so now that we have all of our factors written out, we can go ahead and start canceling our matching pairs. We have an x plus 3 here and here, x minus 7 here and here. Ooh, and another x plus 3 pair. What are we left with? X plus 7 over 8. All right, number 14. Lots of factoring to do here before we can start canceling out. Oops. Quadratic, 15 on top, negative 2 on bottom. Factors of 15, 1 and 15, 3 and 5. In order for these to add up to negative 2, we need a plus 3 and a minus 5. 3 minus 5. Next, 10x plus 20. What do they both have in common? A 10. All right, next, 16 on top, negative 6 on the bottom. 16 is 1 and 16, 2 and 8. Now, how do two numbers multiply to a positive but add up to a negative? They both have to be negative. The rule of thumb is if you have a positive number on top and a negative number on bottom, both factors are going to be negative. All right, and for the last one, again, difference of squares. 25 is a perfect square, x squared is a perfect square. When we square root them, we end up with x is 5. So we need a plus 5 and a minus 5. Now that everything is factored, we can go crazy just canceling everything out. I see a pair of x minus 5s. Ooh, this one we're not going that crazy. Hmm. Okay. I guess that's it. On the top here we have an x minus 2, and on the bottom we have an x plus 2. So that is not going to cancel out. They have to be exactly the same. I must have done something wrong here because negative 2 and negative 8 is negative 10, not negative 6. So I worry that I made a typo on this problem. Wow. Yeah. I'm going to have to change this 16 to a negative. Actually, let's just change the 6 to a positive. No, that's not going to work. Okay. Well, that sucks. 16 on top. If we had a negative 16, and yeah, we need the 16 to be negative, and 6 can stay positive. That way, if the 16 is negative, we need one of our numbers to be negative, not both of them. But then 8 is going to be negative, so that the 2 minus 8 is negative 6. So that's going to work out right there for us. Now change that plus 2 factor, that minus 2 factor right here to a plus 2. And now those two will cancel out. Sorry about that. All right, what are we left with? Bam, 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 bam. Combine it together. All right, the final answer. Okay, number 15. Now, I did make an error on this one, but I caught it before I started the video, so let's fix it really quick. This positive 3 right here needs to be a negative 3. Wait, am I crazy? Okay, I don't know. My paper says negative 3. If yours says positive 3, then the positive 3 is correct. So we have, let's go ahead and start canceling this out right here. Or not canceling out, but factoring. We have 7 and 7. They're both divisible by 7. We divide by 7. We're left with 7 times x minus 1. First denominator, negative 70 on top, positive 3 on the bottom. We got 1 and 70. I know 7 and 10 multiply to 70. And looky there, 7, negative 7, and positive 10 will get us that positive 3. All right, now the next numerator we have is another quadratic, negative 7 at the top, 6 at the bottom. 1 times 7 is 7, and we need them to add up to a positive 6. So that 1 is going to be negative. Now in this denominator, we have negative 21 at the top. I'll do it over here in the margin. Negative 21 at the top and negative 4 at the bottom. So we need 7 and 3, where 7 is negative and 3 is positive. All right, now because this is a division problem, we need to keep change flip. We're going to keep the first fraction, change it to multiplication, and flip the last fraction. Write it. Change to multiplication, and flip the last fraction. All right, now we have a nice multiplication problem with all these factors, and when we multiply, we just factor and cancel out. What are we left with? 7 times x plus 3 over x plus 10 times x plus 7. Let's rewrite it nice and pretty. There we go. All right, number 16. We are almost done. Number 16, we need a lot to factor. Here, another quadratic, 15 on top, negative 8 on the bottom. 3 and 5, the number on top is positive, the number on bottom is negative, so both factors need to be negative. All right, here is 20 divisible by 2. All right, here we have perfect squares. 9 is a perfect square. Square root both of these, we're left with x minus 3, x plus 3. Next denominator here, 100 on top, 20 on bottom. 10 times 10 is 100, and 10 plus 10, 20. All right, because we have a division problem, we need to keep, change, flip. Keeping that first fraction, changing to multiplication, and flipping the last fraction. All right, we are ready to cancel. X minus 3, x plus 10, and that's it. So we have x minus 5 times x plus 10 times 2 over 2 times x plus 3. Let's write our answer nicely. Whew, oh my gosh, that was a doozy. Okay, let's do the number 17. Now for the graphing part. Okay, let's do it. We can get this done within the hour. My pen would keep working. That would be great. All right, so S in Schrady stands for simplify. Factor and simplify, it says. So, does this need to be simplified? No, it does not. Moving on to the roots. The root says set numerator equal to 0 and solve. So we're going to say x plus 2 equals 0, and we need to solve for x. We're going to subtract 2, leaving us with x equals negative 2. Now, the r stands for root, which is literally the x-intercept. So we have an x-intercept at negative 2, 0. Now, a is for asymptote, the vertical asymptote. And it says set the denominator equal to 0 and solve. So x minus 4 equals 0, add 4, And we're left with x equals 4. So we have a vertical asymptote through the x-axis at 4. Let's do yellow. Actually, I'm going to use a ruler because that is just nice. Okay. All right. Now, moving on to T, our test points. We need to choose 2 test points to the left of the line and 2 test points to the right of the line. So starting with our first choice of 2, I'm going to zoom in here, we have x equals 2. We're taking 2 and we're plugging it into the entire equation. So we're going to have 2 plus 2 over 2 minus 4. Plus 2 over 2 minus 4. Now you can stick that in your calculator. I'll open it up so we can see it on here. But that's going to take a while, so I'll just do this one by hand. 2 and 2 is 4. 2 minus 4 is negative 2. 4 divided by negative 2 is negative 2. So my point here is 2, negative 2. Next test point. We said 3. Oh, let me go plot that. No, it's okay. We'll do the plots after. 3. So we have x equals 3. So we have 3 plus 2 over 3 minus 4. 3 plus 2 is 5. 3 minus 4 is negative 1. So our point here is 3, negative 5. Next test point is 5 and 6. So for x equals 6, we're going to say 6 plus 2 over 6 minus 4. 6 plus 2 is 8. 6 minus 4 is 2. 8 over 2 is 4. So our test point is 6. And the last one, I'll show you how to put it in the calculator. We said the other number was 5. So we're going to say 5. 5 plus 2 over 5 minus 4. So go to your calculator. We're going to say parentheses 5 plus 2, close parentheses, over parentheses 5 minus 4. Enter, and we get 7. So that's a little bit easier if you're struggling with the calculations. Our point here is 5, comma 7. Now let's go plot these points. We have 2, negative 2. 3, negative 5. 6, 4. And 5, 7. Fantastic. Moving along to E. E means end behavior. So we look at our graph and we wonder, is this balanced or is this bottom heavy? Well, if the x in the top and the bottom have the same exponent, which in this case they both have an invisible 1 exponent, that means it is balanced. And for the E on the acronym, it says balance horizontal asymptote. Oh, what's happening? Balance horizontal asymptote y equal to the coefficient. So let's see. What is our coefficient on this x? 1 over 1. So our horizontal asymptote is just at 1. Let's go ahead and draw that line. All right, now the last part of our charade is the y. Plug in 0 for x and solve. This is one you can also put in the calculator. This is negative 1/2. So we have a y-intercept at 0, negative 1/2. All right, we can go ahead and connect our lines. Hopefully a little better than me. All right, there we go. Now for the domain and range. Domain and range are always all real numbers except any holes and asymptotes. Our first asymptote is at x equals 4. So I'm say at the domain x is not equal to 4. My second asymptote is at y equals 1. So I'm going to say the range is all real numbers except y is not equal to 1. The reason why we put x on the domain and y on the range is because domain literally represents the x values and the range also represents the y values. So x is for domain, range is y. All right, next problem. I see, starting with the s, we do need to simplify that denominator. So we can do our work right here next to the s. We're going to have a top of 12, a bottom of -7. Our two factors are going to be 3 and 4. Now, when your top number is positive and your bottom number is negative, both numbers are going to be negative. All right, now I can see that that top factor cancels out with the bottom. We are not left with nothing on top. We're left with 1 over x minus 4. So this is what we'll be using going forward. All right, any wholes? We take the canceled factor. What we canceled was x minus 3. So we're going to take x minus 3 and set it equal to 0. Solve for x. We get x equals 3. Now, the x value of the whole is 3. We don't know what the y value is yet. So we're going to take 3, plug it in for x in the simplified equation, leaving us with 1 over -1, so 1. Okay. So let's go ahead and plot our whole at 3, -1. All right. Next, roots. We take our numerator, which is 1, and set it equal to 0. That doesn't have any x values in it. Does 1 equal 0? No. We have no roots. Now moving on to the asymptote, it says set denominator equal to 0 and solve. We're going to add the 4, get x equals 4. This is our vertical asymptote. Let's go ahead and plot it. X equals 4. All right. Now the test points. We need 2 to the left. Ooh, I'm realizing I made a little mistake. This point right here, I literally said it's a hole, and for some reason I still drew a closed circle. This is a hole, open circle. Okay, now coming back to my test points, we already have a point at 3, so we don't need to do that one again. We're going to do -1 and 2, and 5 and 6. So our first one is x equals 1, x equals 2, equals 5, and 6. So plugging that in, we have 1 over 1 minus 4, 1 over 2 minus 4, 1 over 5 minus 4, and 1 over 6 minus 4. Let's put these in the calculator. 1 over 1 minus 4. -1/3. Okay, 1 over 2 minus 4. 1 over 2 minus 4. -1/2. 1 over 5 minus 4. 1 over 5 minus 4. 1. And 6 minus 4. 1 over parentheses 6 minus 4. 1/2. All right, plotting our points. We have a point at 1, -1/3. 2, -1/2. 5, 1, and 6, 1/2. All right. Next, we move on to the E, end behavior. Balance or bottom heavy. You look at our simplified equation. Notice how there's no x on top to balance out that x in the bottom. So this is bottom heavy. And E from our notes says bottom heavy, HA, is y equals 0. So let's go ahead and plot that. Y equals 0. There we go. And the last one, y-intercept. Plug in 0 for x, solve. 1 over -4. So we have a y-intercept at 0, -1/4, which is going to be really close to this line here. Let's go ahead and connect. Okay. All right, that's it. Let's talk about the domain and range. It is always all real numbers except wholes and roots. So we do have a whole. The x value is 3. So I'm going to put that with the domain. For the range, the y value is -1. Y is not equal to -1. Now we have an asymptote at x equals 4. I'm just going to put a comma and add the 4 to the domain. And the other one is at y equals 0. So I'm going to put a comma and 0. That's it. All right, well, thank you for watching my video. I hope you continue to study for your test. All right, well, good luck.